right, so start off Unit 3, proportions using, I don't know why I wrote graph, that's my bad. Title should be proportions using a table. I don't know where that came from. So just to review, a lot of Math 7 involves proportions and ratios, so this should be kind of second nature by now. But a proportional relationship is a relationship between two or more sets of numbers where the ratio of one number to another is constant. Now that's a very confusing sounding definition, but basically what it means is that we have equivalent fractions. Just like our warm-up yesterday, 1 over 2, 2 over 4, 3 over 6, 4 over 8. We could keep going like this forever and ever and ever, making equivalent fractions. The question is, are these ratios proportional? Give me a thumbs up if you say yes, these are proportional. Thumbs down if you think no, these are not proportional. Based on this definition, what do you think? And thumbs in the middle if you have no idea, which is fine too. Good. Okay. Lots of thumbs in the middle. So let's break this down. If we have 1 over 2, right, and we have 2 over 4. Let me grab a whiteboard, actually. If we had the fraction 2 over 4, right, and we were going to break this down like we did in the last unit, 2 times 1 over, what two numbers multiply to give me 4? 2 times 2. Is there any pairs we can cancel out here? Yeah, we got a pair of 2's right there. So what are we left with? 1 over 2. Is that equal to 1 over 2? Yes, it is. What if we took 3 over 6? Right? 3 over 6, let me move it down. 3 over 6, on the top we got 3 times 1. On the bottom we got 3 times 2. What can we cancel out here? Pair of 3's. What are we left with? 1 over 2. Is that the same as 1 over 2? Yes, it is. So that's how we can tell these are proportional. Basically, it just means that they're equal, but they're different sizes. Right? 1/2 and 2 over 4, those represent the same amount. If you cut a pizza into 2 slices and eat one of them, you ate half the pizza. If you cut it into 8 slices and eat 4 of those slices, you still ate half of the pizza, right? If we think back to our little elementary school fraction learning. So the question, are these proportional? The answer is going to be yes. Now this may still sound a little confusing. That's totally normal. Once we get to the actual work, you'll see that it's really not that bad. Let's talk about the constant of proportionality. How do you spell this? Proportionality. That's a super long word. Proportionality. What does the word, not even in a math sense necessarily, but what does the term constant mean? Who can explain? What does it mean? Repeating. Good. What else? Definitely repeating. Yeah. Over and over. Absolutely. Right? And the same. So let's add those 3 little terms in here. Constant. So I love those. Constant. Repeating. Over and over. Or the same. So keep that in mind when we're finding this constant of proportionality. We're looking for a repeating pattern that we see over and over that is the same every time we compare 2 numbers. So the formula for finding the constant of proportionality, let me figure out what colors I want to use here. we're going to use the variable lowercase k, k for constant, even though constant starts with a C. K is going to be equal to y over x. Like I said, this might not make a whole lot of sense right now, but it will once we see the actual work. K is equal to y over x. K is the variable. That represents our constant of proportionality. Constant of proportionality is a very long phrase to repeat over and over again, so we're just going to call it K. So if I say, let's find K, that means we're going to find the constant of proportion. I can't even spell it again. Proportionality. Like personality, but with a proportion. So we're going to call that K. Don't ask me why it's K. I have no idea. I didn't make that up. Some old Greek mathematician made it up a long time ago. That's what we're going to use, K. So that's how we're going to use it. Or I should say, let's see how we're going to use it. My bad. This minimum days got me all brain all over the place. K is equal to y over x. So we're going to have a table. A horizontal table with x values and y values. X values on the top, y values on the bottom. Go ahead and draw 8 little boxes there. 4 x value boxes, 4 y value boxes. And for our x values, let's go 1, 2, 3, 4. Start off nice and simple. 1, 2, 3, 4. And then our y values, let's go 2, 4, 6, and 8. I'm going to move this down. There we go. X values of 1, 2, 3, and 4. Y values of 2, 4, 6, and 8. Now in this table, each of these columns, this column here, column 2, column 3, column 4, each of these columns have an x value and a y value. If you think about what we did yesterday on that worksheet with the little dog's face, when we have an x value and a y value together, what can we make on a graph? What were we able to plot yesterday? Anyone remember? A point, right? An x and a y value make a point. If we look back at this, right, this point B right here has an x value of 4 and a y value of also 4. Whenever we have an x and a y value together, that gives us a point on a graph. So we're not going to be dealing with graphs today, but that's where we're headed with this, just so you know. So this table represents 4 points. A point at 1, 2, 2, 4, 3, 6, and 4, 8. what we have to do with this table is find k. We have to find what our constant of proportionality is for this table. Do you have a question? Oh no? My bad. I thought I saw it here. So we're going to find k. Well, what is k equal to? Is there a formula we wrote down that can help us find k maybe? K is equal to y over x. So if we want to find k for this table, it's very simple. We take a y value, like 2. That's going to go on top. And then what's that y value's x value that goes along with it? 1, right? 2 and 1 are in the same column. We're going to put 2 over 1. And that gives us what? What is 2 over 1 equal to? Just 2. That gives us an idea that our k value, our constant of proportionality here, is most likely going to be 2. But we have to make sure that we check each of these points to see if we have a proportional relationship. So what would my next fraction look like? We just did 2 over 1. What can we set up in a fraction now? 2 over 4, very close. 4 over 2, y over x. And this is where a lot of small problems happen, is when we put x over y. The way that I always tried to remember it in my head to put y over x is asking myself the question, why aren't you over your x? Okay, did you hear what I said? Why aren't you over your x? Why aren't you over your x? Why aren't you over your x? If you put that in your head, when you put this fraction together, you're always going to want to put y over x. Or you can say, why are you over your x? Either one, depending on where you and your x stand. Hopefully, I mean, you guys don't have x's. You're like 13, but that's how you can remember it. I always try and find ways, like when I was learning in middle school and all that, I always tried to find ways that formulas would stick in my head because it made it a lot easier to remember. So just ask yourself, why aren't you over your x? So you can put y over x. I'm going to add that in right here. Good morning, Ashley. So if that helps you remember y over x, you could add that in too. If not, that's fine as well. Whatever works for you. Thank you. Why aren't you over your x? So if you get to this table and you're like, wait, what do I put on top, y or x? Just think, why aren't you over your x? Oh, y over x.
I was not covered that one.
Okay.
And my mom said she only went to like bring me back. So I went to the office for like letters. They said that they don't have any. And they said I should ask my teachers each period if they have a Chromebook.
Yeah. Yeah, I do have an extra Chromebook, but we're actually not going to be on the Chromebook. We're just taking notes right now, and then we have a worksheet.
After school?
Yes, after school today. Are you going to be able to come by? Okay, perfect. You can have I'll give you your test then, and we can take it, okay? So, our second k value. Now that we know why we aren't over our x, we say k is equal to 4 over 2. What is 4 over 2 equal to? 2. Thank you, Darius. 4 over 2 just simplifies to 2. So far, we've got the same k value for both of those points. But let's keep going. K is equal to what over what? 6 over 3. We take a look at the next point, right? We did 2 over 1. We move over. We did 4 over 2. Now we're going to do 6 over 3. And if we simplify 6 over 3, what do we get? 2. So far, so good. All of our k's are checking out. We got one more to do. What's that last fraction going to look like? 8 over 4. Exactly. Why aren't you over your x. Y over x gives us 8 over 4. And what is 8 over 4 simplified to? 2. Boom. All 4 of our k's that we found are the exact same number. So we can say all of our k values are the same. So this is a proportional relationship. Where k is equal to what? What's our k here? What number did we just find 4 times in a row? 2. K is equal to 2. K is equal to 2. Just like that. Any questions I could answer about that process? I know it was kind of long-winded, but it's simple enough, right? For the most part, hopefully. You're going to see what the y's are. You're going to see what the x's are. All you have to do is divide y over x. Y over x. Y over x. Y, aren't you over your x, right? Just like that. So if we take a look at worksheet 12 that we're about to get, we got a bunch of tables with x values and y values. All you have to do is find the constant of proportionality, or k, in each of these tables. So at the top, I would just write k is equal to, what again? Y over x. Y over x on the top. So if we look down at, let's say, number 2 for a second, just so we could do one together before you get this worksheet. The first thing we're going to do is write k is equal to, what's my first fraction going to be? What's going to be on top? 9 over what? 3. So take a look. There's one fraction. There's 2 fractions. There's 3 fractions. But if you just keep it like this, you're doing the opposite of what we want to do. So you want to do y over x. 9 over 3 is equal to what? 3. Well, we got to check to make sure they're all equal to 3. What's my next fraction going to look like? Thank you. 18 over 6. Good morning, Brooklyn. 18 over 6 is equal to what? How many times would 6 go into 18? 3 times. What's my last fraction going to be? 27 over 9. How many times does 9 go into 27? 3 times. Take a look at that. We got 3, 3, 3. My k here is equal to what? 3. Nice and simple. If you know how to divide and simplify fractions, you're good to go. The trickiest part is just figuring out the order, what goes on top, what goes on bottom. If you ever forget, just ask yourself, why aren't you over your x? Y is going to go over x.